on your startingly I have downloaded something on your computer which is called everything. Okay, so what everything will do, it will be doing the indexing also. Whatever you search it, whatever you put it on your computer, it will automatically index it and it will show, because it will speed up the process. So that is your index. And then you have transaction in the middle right. Okay, in the middle right you have transactions. Okay, so these are your transaction. So this will have a shield, okay, protecting all the transaction block. Okay, then show begins the transactions. Okay, then it will query, all that it will be done. Okay, once you do commit. Okay, so that commit, it will emphasize all your atomic consistency and isolated and durability properties, all it will take care. Okay, so it will begin with begin and it will end with commit. Okay, then we have something called normalization. 1f 1nf 2nf 3nf. Okay, so this will show the elimination of the values, atomic values and partial dependencies and transitive. Okay, it will remove that dependency. Okay, so we will see that how the reduce, it will be reduced your dependency step by step here. Okay, so we will see how it will reduce the dependency. So I will explain you in the further chapters. Okay, so then you have trigger here. So you have view here. Okay, normalization, then we will go with the view here. Okay, so this is your virtual table layer. Okay, so which will be built on your base table. Okay,
Sir, 1 second, I'm using my microphone. Voice is here. Just a second, okay?
okay,
Just
okay,
a second.
yeah. Start the recording. Okay. Okay, there will be 3 triggering points here. Okay, in the database. Okay, on insert, whenever you call on insert, you will have a triggering point. Okay, so you will have a log entry on insert. Then on update also you will have audit trail. Okay, then you have on delete. Okay, so all it will be triggering point which will have a check. Okay, so there will be automated response for the data change. Okay, so this is how it will be done. Okay, these are the database concept. Okay,
Is that change?
yeah, any changes. Okay, automated response for the data change. See, if you are inserting something, you are changing something, right?
Yes.
If you are updating, then you are changing something.
Yes.
If you are deleting, then also you are changing something. Okay,
Something other than.
yeah, so that is why it will have a trigger. Okay, so those are all the trigger points. Okay, so let's say how it will work. Okay, one by one we will see the flow here. Okay, so let's say, so I want to see the data integrity and structure. Okay, so my primary key is the ID card for a row now. Okay, it ensures that every record in the table is unique, making it easy to find specific information. Okay, foreign key is the bridge here, bridge between tables. Okay, it links data in one table like an order to related into another like a customer, ensuring the relationship between your data remain intact. So the data should not be modified. This is why you will have a foreign key. Okay, Then we have normalization here, 1NF to 3NF. Okay, this is the organization process. Okay, so it is used to clean up data. Okay, removing duplicates and then ensuring that each piece of information is stored logically. Okay, so like this you will have data integrity and structure. Okay, then we have something called performance and access. So let's say you have index here, this is your search shortcut. Okay, just like a index in your book. Okay, it allows the database to find a specific row instantly. Okay, without having to scan your entire database, entire table, which will significantly improve your retrieval speed, data retrieval speed. Okay, then you have something called view. Okay, so you see it here, view. This will be your custom filter. Okay, a view is saved. Okay, virtual table based on a query. Okay, it will let you know, it lets you to present the complex data in a simple way without changing the underlying base table. So like that you will get performance and access. Okay, now we need to have a reliability and automation. So how you will safeguard your atomicity access? So now it comes your transaction. Okay, this will ensure that the series of database operations like moving money from the between bank accounts either succeeds completely or fails completely. If one step breaks, the system will roll back. Okay, to prevent the data corruption or partial corruption. Okay, so this will ensure that the transaction is complete or rollback. Okay, then you have something called automatic assistant here. So this is your trigger. Okay, this is a block of code. Okay, that automatically runs when a specific event is happened in the database. So just like we saw these three, it will automatically create a log when a new row is inserted or you are performing a security check before a delete is going to occur. This is how you will be performing the reliability and automation. Okay, so let's say we will take one example. Okay, you use specific keywords when altering or creating or altering the tables. Okay, these commands tells the database engine how you are going to enforce the rules on the data. Let's say you are creating a table. So I will create a table here. Okay, so let me copy paste one table here. Okay, SQL. Okay, create table customers. So ID primary key. Okay, this is the command. Okay, ensures ID is unique and not empty. So name is your character 100 characters. Okay, so this will ensure that column contains unique value and cannot be null. It acts as a specific, it acts as an anchor for a specific record. Okay, then we have something called foreign key. Okay, foreign key will prevent actions that could break the links between the tables. So between the tables you should have a link. Okay, let me get one table here. Okay, so in that table only I will create it. Okay, so you have created a orders table. Okay, so this foreign key customer ID, okay, it will prevent actions that could break the links between the tables. Okay, it ensures that the customer ID in the order table actually exists in the customer table. Okay, so it will ensure that this is exist in the customer table. Okay, then we have something called normalization. So you will know what is the normalization here. Okay, atomic value, no partial dependency and non-transitive. Okay, so this is the design. Okay, rather than a single command. Okay, you will implement it by breaking the large or clustered tables into small tables. Okay, so you will avoid the data duplication.
Yeah.
Okay, let me give you this. So we will see that data normalization in other class. We will see it. Okay.
Uh, for by what will this avoid the duplicate then? By
So
what? By normalization or
normalization.
by what will avoid the duplicate? By in what topic? Yes,
So
you said no.
sorry.
You said no. You will avoid the duplicate data. So
Okay.
how?
O-
Yeah, can you explain this?
Okay. So it will, let's say normalization is a design strategy. Okay. Let's say 1NF. Okay. I will type, okay, 1NF. Okay. Let me take the pen here. Okay. I will draw it here. Okay. So 1NF is, what is this? Okay. Let me select this pen here. Okay. So you have 1NF, okay, which is your atomic value. Okay. So it will ensure that each cell, okay, each cell contains only one value. Okay. It should not have, okay, I will have, okay, what is your date here? Okay, let me. Uh, so pen is not working properly. Okay. So let me give you an example. Okay. So this atomic value, okay, it should not have two values. Okay. Customer ID. If customer ID you are putting, then you cannot have a comma and one more value. 203 a comma 204. Okay. That is your 1NF, means atomic value. Okay. Then you have 2NF. Oh, what happened to this? Okay. 2NF is no partial dependency. Okay. Let me get it like ensure all non key attributes rely entirely on the primary key. Okay. There should not be a no partial dependency. Okay. This got closed now. Okay. This is a new pen. I am having issues with this. Look, I will put this aside. So I will use a mouse only, okay, for time being. So 3NF, okay, normalization, okay. So ensure that it will ensure that no key values, no key columns, okay. This is row and this is column, okay. No key columns do not rely on other non-key, okay. So that once you do that transaction, then you will come to know, okay. So that is your proper database design. It will be like table splitting it, okay. That is where you will have a data integrity. You will ensure that the data is intact. It is not tampered. So that will be your normalization, okay. So let's say you are handling updates, primary key, okay. So let me take one example here, okay. Okay, you have your table ID here. So you configure your foreign key, okay, to automatically update the child record here, customer ID, okay. So you have customer ID, okay, then you have foreign key as a customer ID, okay. Order ID is your primary key. This is your foreign key, okay. So you configure your foreign key to automatically update the child records if the parent primary key changes, okay. So you will be doing this on update. So on update, cascade to your foreign key definition, okay. So you will be updating that as well. So that is what it will be, directly approach, your cascading direct approach. Then you have something called surrogate key, okay. So this will be used to this is a artificial, okay. So it is like identifying like a automatically incrementing integer or UUID, okay. So I will get it a graphical diagram of this, okay, then you will understand it, okay. So let me give you this example, okay. So I will get one graphical presentation of this, okay. So now you have here primary key, okay, you are handling it. So your primary key, you have your user ID here, okay. So here your email, okay. So unique ID auto increment, okay. So now your 789 is immutable, you cannot change it, that is stable, okay. So login ID is 789, okay. This is the artificial identifier, immune to change business requirement, okay. So here you cannot change the user ID here, even if the user ID is like this, okay. Then the cascading ID is update is, it will keep on changing, okay. Let's say you have a product code here, okay, instead of SKU A1, okay, this is your parent, okay. So your product code you are changing. Let's say you have a iron box, okay, which is of a company Philips. Now you are changing that code to some other, to Bajaj, Okay, once you change it, the child here, okay, this will automatically get changed in the parent here. So this is on update cascade. Okay, child data updates to maintain referral integrity. Okay, so once this child got updated, the parent will also get updated. That is what the primary key is in the cascade. So now you understood it. Okay, so by diagram you will understand this. Okay, so now you have let me go to the our SQL commands, DDL commands we will go. Okay, so you have seen the DDL command, right? Data definition language,
Yes.
which is your drop, create, alter and truncate. Okay, so I will take the example, this we have used it. Okay, so I will use the same methodology here. Okay, so graphical presentation, will take one graphical presentation of this. Okay, so now you are creating a table here, create table employees. Okay, so the database adds empty table structure. So once you execute this, it will be automatically created like this. So you have here use company HR, this is your database. Okay, then you click go. Now you are creating the table, this is your comment. Okay, you are creating employees table. Okay, this is done, first step. So now it will create an empty table. So then you want to alter here, alter table employees, add salary decimal. So you are adding the salary here, you are entering it, the salary here. Okay, so you are entering this column here. Okay, now the third option. Okay, third option is, okay, so your goal is to truncate it. Okay, now you are executing branching here. Okay, so you are executing this. Okay, if you want to delete all the data but want to create the table structure here, so you want to delete everything. So truncate table 1 employees means you delete all that details here, but maintain the table structure here. This is your 3A option. Okay, then you have 3B option. What is the 3B option here? You want to drop the tables. Okay, you delete the tables also, I don't want the structure also, so you delete it. This is what happens if you do the DDL commands. Okay, now you have DML. Okay, which is your insert, update and delete.
Yes.
Okay, so now we will go with the same. Okay, so we'll see the table definition here. Okay, I will get it. One more query here. Okay, let me copy this query here. Okay, so I have a query here, table DML, primary key, all that. We will see that how that will be done in the graphical presentation. Okay, so now you have here something. So you are setting up the tables and constraints. Okay, so your primary key is ID. Okay, ID primary key. Okay, so you are protecting it. You have a protection here. This is your primary key. then that is done. First you created it, then you are inserting new records to the table. Okay, now you have added the tables here. Okay, so you added John Doe, salary, Jane Smith, Bob Johnson, all you added. Okay, so new table, so you inserted the record. Okay, so now you want to retrieve it, you want to select the data. Okay, select from employees underscore DML. Okay, so you are extracting the data. Okay, result 1 and result 2. Okay, so you see it here. So first one is you are selecting all, this is your first select. So you have selected all rows and columns. Now the second one, result 2, name and salary, and you have put the condition where salary is above 60,000. Okay, Jane and Alice have come. Okay, this has filtered it. Okay, so now you are updating the records, now you are modifying it.
Okay, you use here where condition.
Okay,
I'm asking you use second one, use where condition, where salary is greater than 60,000.
yeah.
Okay.
Then it filtered out the less than 60,000, it removed it. Okay, so it is only displaying, but the data is inside the table, it is not deleted. Okay, so you are just selecting it. Okay, so then you are modifying some existing record. Okay, so third one you are doing a modification. Okay, so now update employees DML underscore demo table, you are using that table. Okay, set salary is equal to 72,000, where employee name is Alice W. Smith. Okay, so here you have Alice Williams and Alice Smith. Okay, and where ID is 4. So if you have any conflicting, okay, so you are modifying the existing data with the where class here. Okay, so it will prevent the accidental updates. So only if the ID is 4, it will update here. Okay, so now you want to remove the records here. Okay, so now you are updating here, select from employees DML where ID is equal to 4. Okay, so this will select that particular employee. Okay, then you are deleting the records here. So delete from, this is your table. Okay, where ID is equal to 3. Okay, so it will remove a specific row, only that specific row will be removed. Okay, so now here you are giving an accidental deletion, delete multiple records based on a condition. So delete from this table, okay, where the salary is less than 55,000. Okay, so all the salary less than 55,000 will be deleted. Okay, so then you are verifying the deletion. Okay, so then
What does mean they verify the deletions?
so you are selecting whether you have deleted or not. Okay, all the 55 and 50,000 should be deleted. You see it, John Doe got deleted and Bob Johnson also got deleted. Now you want to select it from the employees, you are seeing that. Okay, so now you got only 2. This is your DML query. Okay, so now you have manipulated this data here. Okay, So you inserted, you selected, updated and deleted. All the actions have been done. Okay.
Yes.
So now we will see the query language here. Query is only selector. Okay.
Okay.
Let me get one select query. Okay. So you have a select query here now. Okay. So you have set up the employees name, salary, where ID is equal to 1. Okay. Then you are doing a you are setting up a temporary table. Okay. So let me get it. We are creating a temporary employee table here. Okay. Let me get it graphical so that you will understand. If I keep on telling, you won't get it. Okay. That is why I created a graphical picture for every explanation. Okay. Now you are setting up a temporary table. Okay. Local temp db. Okay. You are creating a local temp db which is not null. Okay. Here you are creating a temporary table. Okay. So you have here id. Okay. id you have logged it. Okay. And then so all you have mentioned it, name, department and salary. Okay. Then you are inserting the data here. So your sample data you inserted. Okay. So this one is done. Okay. Then you are selecting the salaries here. Okay. So you are retrieving all the information which is present in the table. So you are using select asterisk from the employees temp. Then it will fetch all the rows and columns. Okay. So everything it will be displayed here. That is called wildcard.
Okay. What is the application called and grouping application and grouping?
Sorry.
There is a first setup like and then compound filtering.
Where is that?
In the graphic, the graph.
Okay.
Why you deleted? Yeah, this one.
Uh,
Number 7.
we have not come to number 7, right? We are in number 1 only.
So you said now you do step by step that or you are talking about setup only.
So step by step, let me come it. No, I will come at 7 now.
No, why you are I don't know.
Sorry.
Which point you were doing number 1, 2, 3.
We are doing at number 1. Okay.
Yeah, that is.
This is your select. Okay. Are you able to see my screen?
Yeah, now I can see now because it was not maximized. Now you maximize I can see.
Okay. This is where you are seeing this. Okay. You are selecting it. Wildcard entry. Everything you display. Okay. So you should be very careful if you are using this asterisk. Okay. Because the complete table will be displayed. So if it is small, then no problem. If it is big table means all the database it will be completely displayed. So that you should be careful when using the wildcard entry. Okay. So then you are using a projection now. Okay. Only specific columns you will be doing it. Okay. This will reduce your network traffic and improve performance. So just now I told you, right, be careful with asterisk here. Okay. Now we are selecting select name department salary from employees table. Okay. So you are very specific about now. Okay. You select only 1, 2, 3 columns. So maybe you have 40 or 50 columns in here. So you are just asking, okay, you go ahead with only 3. Then only that data will be retrieved. So that is your second query. Okay. So then we have something called third one. Okay. You are filtering with where. Okay. So where is, you need to match the specific condition, then only you show me that. So it will be like filter. Yeah.
Hello.
Yes.
I could not hear you. Can you repeat?
Okay. You give me where the condition is met. So without that you don't display anything. Okay. So let you fetch the data where my condition met. Okay. This will filter the rows before they are returned. Okay. So then you are selecting salary name. Okay, from employee tables where department is equal to IT. Okay. So only the IT employees will be displayed here. Okay. Then you have something called compound filtering. Okay. So you are using and or operator. Okay. So select name department salary. Okay, from table where department is equal to HR and salary. Okay, or I can put it as, okay, or IT department. Okay, and salary. I can go on like that. Okay. So I have only put one condition where department is HR and the salary is more than 53,000. Okay. Then it will be based on the multiple conditions, it will display. So that is your compound filtering. Okay. So then you have something called sorting. Sorting by order. Okay. Arrange the retrieved data in an order, ascending or descending. Okay. Ascending or descending, you just arrange me like that. Okay. Select name salary from employee tables. Okay. Order by salary description. Okay. Shows highest paid salary of the employees first. Okay. If you filter it like this, it will arrange the data like whoever is having the highest paid. Okay. Then you are limiting the result now. Okay. So now you want to see, okay, only the specific number of rows. Okay. So you are using the top n records. Okay. Select top 3 name salary. Okay, from employee tables. Okay, then you order by the highest paid employees. Then it will give you the top 3 employees who have the highest salary. Okay. Then you have aggregation now. Okay. Aggregation is you either count it or you perform a calculation. Okay. Count ID as total employees. You tell me how many employees are there. So that will give you the number of the employees. Here 5. Okay. Then sum of the salary as total payroll. Adds up all salary. Okay. Here. Okay. Then average salary. Okay. You calculate the average salary and remain it as a mean salary here. Okay. Then what is the max salary? So you find out the maximum salary that they have here. So then it will pick up that highest salary and the lowest salary. Highest and lowest.
Yes.
Okay. So this is from the table, employee temporary table. Okay. That is your aggregation. Then we have something called grouping. Okay. So you group by the department. You group by salary. So you group by employee nationality. So you can do by you can do the grouping here. Okay. Select department. Okay. Count ID, you are counting the employees as employee count. Your average salary as average department salary from employee tables, and then group it by department. Okay, don't display it. You just group it by department and you order it by average department salary. Okay. So whoever has a highest, you just order by average department salary and display that. Okay. Then you are filtering it out. Filter groups having a particular class. Okay. So you will be filtering, okay, where the filters apply before the rows doing the grouping. Okay. Having that filters. Okay. Let's say you select the department average salary, okay, as average department salary. Okay. From the table, employees temporary table. Okay. Group by the department. Okay. You group by the department having average salary greater than 60,000. Okay. Only show the department. So it will show only the department where the average salary is 60 greater than 60k. So it will show only that particular department. So this is all your query language. So you are just using select in every query. You see it here. So all are select command only. Here you are selecting it, you are grouping, then you are selecting. All are select commands only. Okay. So you are just querying it. Okay. You are not doing anything. So then there will be no triggers here. Then first in the initial beginning of the class I told you, right, there won't be trigger for query. Only if I am doing any update or something like that, then only it will have a trigger here. So on query there will be no trigger here. So if I update or insert, then there will be logs. So that logs, you know how it will get updated there. So day before yesterday we saw, right, how those logs will generate, how those get updated, all that. Okay.
Yes.
So that is your query language. So tomorrow we'll continue on the transaction control and DCL. Okay.